Okay, today we are going to figure out how to make a confidence interval, and we're going to do this specifically for proportions. In your calculator, this is going to be called a Z interval, and I'll go ahead and turn my calculator on so I can show you that, because one of the ways we'll do these is in calculator. This video, we're going to do it mainly by the old-fashioned way, to where you would use your charts that were given on the AP exam. And then in the future, we'll do both. But confidence interval for proportion, this is, like I said, it's called Z. And this hashtag picky, P-I-C-C-I, pronounced picky, a young invention. I still don't know what a hashtag really is, but I think it has something to do with MySpace or something. But you kids seem to like them. So picky is how we're going to remember every time we do a confidence interval. We're going to follow these 5 main steps. In your calculator, if you go to the stat menu, and yours might look a lot more modern than this, but if you go over to test, this is a Z interval, option 7 on my calculator. And I will show you how to use that in a little bit. Okay, so before we get into the numbers, here's how we remember what to do. First of all, P is per parameter. On your paper, you need to write down what parameter it is that you are trying to estimate. And for us right now, that's proportion. Our next video will be over means. This one's over proportions. Everything we do, is it a yes or no question, in which case we're trying to figure out what proportion of people would answer yes, or is it a number that they're giving us? We are in proportion land right now. All right, so for example, this might be the actual proportion of teens in America who have vaped this year. There's a good one. All right, vape as in smoked an electronic cigarette. Whatever it is that you're trying to estimate, all right, you're trying to come up with you're using your sample to come up with a proportion that we hope is close to the population parameter, that unknown magic number that's out there that only the wizards know about. All right, so that's your first thing. Just get it out on paper, what it is you're actually doing. That will help you get the ball rolling. Next, identify the confidence interval you will use. For us, since this is the first one you've learned how to make, there's really not many options. All right, I'm going to use a Z interval. Specifically, what you're doing is a 1 proportion Z interval. You might have noticed in your calculator there's sometimes 1 proportion, 2 proportion, 1 sample, 2 sample. If it doesn't say 2 proportion, you can assume that it's 1 proportion, but that's technically what we're doing. We're doing a Z interval. All right, so far no choices there. Conditions. What needs to be true if you're going to construct this interval? Well, we learned in the last one it needs to be random, normal, and independent. All right, so random just means SRS. Okay, the people were chosen with an SRS, and sometimes in practice that's difficult to do, and you might have to say something like, I'm going to assume that this selection of people or subjects is random. You might have to assume that, and a lot of times in real life it's okay to assume that. Normal. Okay, in our conditions up until now, to check that it was normal, we did NP and NQ both greater than 10. It's kind of hard to do that because we do not know P and Q. Basically, we don't know P and 1 minus P, so it's impossible to check that for sure. So what we're going to use is P hat. All right, the sample proportion in P and in Q are those greater than 10. And really, what it comes down to, the successes and failures need to both be greater than or equal to 10, at least 10. We'll use our sample data because we don't know the population data. And you just need to make sure that the people that said yes and the people said no, or whatever, it might not be a yes or no question for people. It might be, is this poker chip blue or not? The yeses and the nos have to be at least 10. That's our normal condition. So 1 was random, and that one's pretty self-explanatory. 2 is normal. And 3, independent. That is that we do not use up at least, we do not sample more than 10% of the population. So let's see, we've checked SRS, successes and failures. This one would be sample is less than or equal to 1/10 population. And this is our independent condition. All right, random, normal, and independent. Those are going to be the same a lot. The way you check them will be different for means and proportions, some of them, but random, normal, independent for proportions look like this. All right, calculate. Do the actual math, find the interval. I'm going to make some more space for this one because there's a lot of our notes will involve this. All right, so I showed you the basic format in the last video. Let's make it a little more specific. Okay. When you calculate the interval, what you are doing is you're taking your statistic, your estimate that's the only number you really know, and you are adding and subtracting from it the margin of error. So in most basic terms, we have the statistic, which would be, 0.47, 47% of teenagers say they vaped, or whatever, or 0.2 because 20% of the poker chips we looked at were blue, plus or minus margin of error. And this is the number based on a normal curve that we are going to add and subtract to make sure we are blank % confident we actually catch the true number, like the dinosaur with his outstretched arms. To make it a little more particular, the margin of error is made up of 2 parts. The critical value and the standard deviation of the statistic, or the standard error. And now let's get real specific. When you want to do a Z interval, we can fill in some specifics. The statistic is p hat. All right, we have that symbol already. That's the proportion that is estimating p, the true unknown proportion, plus or minus. Critical value is going to be called Z star. Just a minute, I'll tell you what that means. And the standard deviation of the statistic, that is the standard deviation of the sampling distribution, with one slight adjustment. We have always used square root of PQ over N. Again, since we do not know P, we have to use the square root of P hat, Q hat over N. And again, I like Q instead of 1 minus P. Just for memory purposes, but 1 minus P, if one of them's 70, the other one's 30. Remember, we don't know P anymore. The question is not going to say, well, assume the true value is blank %, and we just trust that. Now, the only number we really know is P hat, the percentage of our actual sample that said yes or fit into a certain category. So we have to use P hat and Q hat in our margin of error for the standard error. All right, so here's the calculations. The only numbers you know are sample size, what percentage of your sample was a success, and now what's up with this Z star. All right, hang on, I'll show you what's up with Z star. If you look at this table, which is on your Goldie and Pinky, and it's in your book, And it's nothing really that you don't already know about. This bottom line where the infinity is. Now we'll talk about why that's infinity and why the other lines are 1,000 and 100 when we start talking about means. But for proportions, this is ZStar. All right, you should have a textbook at home. Look in the cover, the front or back cover. I think it's in the back, maybe not. But look in that and find this table. So let's talk about what it means. Let's use 95 because a lot of the time we use 95. The Z-star level for 95% is 1.960. When we do the 95, the 68, 95, 99.7 rule, the two standard deviations out that correspond with 95% is actually an estimate of that 1.96. It's not really 2 steps, it's 1.96 steps. It's just easier to go with 95 than I think it's 95.4. So what that Z-star value is, it's the Z-score that has C% in the middle, right? If you want a 95% level, then you would go left 1.960 and right 1.960, and you would encompass 95% of the possible area in the normal curve underneath your graph. You will use 1.960 for Z-star more often than any other level. All right, so I know this is a big table and you're not really writing down notes at this point, but add to your notes these values. 80 is pretty rare, but we'll include that too. By far, these are the most common values. If they ask you for 98, you'll have to come to this table and get the 2.326. But write down 80 Z-star equals 1.282, 90 Z-star equals 1.645, and so on. All this is, like I said, is the Z value corresponding to the interval with 95% in the middle or 90% in the middle or whatever. Okay. So let's get one quick example in. Well, first the interpret. The interpret was on your last video. Every single time you calculate a confidence interval, you should finish with this sentence. I am, or we are, it doesn't really matter, blank % confident that the interval, and this interval might be like 0.45 to 0.49 if you're in proportion land, or it might be like 6.8 to 7.2 if you're in mean land, captures the true blank. In this case, this is going to be the proportion in context. This is basically the thing that you stated for your P for the very first step in this picky process. 95% confident that the interval blank to blank captures the true. You got to have the context. That's huge on the AP exam. All right, so PICCI. This is the 5 steps. We're going to do 5 or 6 different types of confidence intervals, but every single one of them should have these steps. All right, so quick example. Okay, so here's a nice, simple, typical example. 100 PLD students were asked if they have taken at least one AP class. 37 said yes, given 90% confidence interval for the true proportion of PLD students who have taken an AP class. So this is different now. The only number I know is that 37 out of 100 said yes. All right, so remember our 5 steps. Identify the parameter you wish to estimate. This is basically just restating the question. You might feel like this is a waste of time, but I promise you it is not. Also, on your AP test, you don't want to write PICCI. That is something made up and sort of silly, but you do want to do those 5 things. I want to estimate the true proportion, true just for emphasis, you don't really need to say true, I guess, of PLD students who have taken AP. All right. Next, the I. What interval am I going to be doing? I'm going to be doing a one proportion Z interval. All right. We'll talk about comparing two proportions later, like what percentage of or how's the difference in percentage of young students versus Kennedys who pass the test, which is obvious. But right now it's just one proportion. There's one number I'm trying to sum up, and there it is. Conditions. What conditions need to be true? Well, I did not say that it was an SRS, so what I need to do is assume the 100 were an SRS. I should be using context. Forgive me, I'm just trying to keep this video short. Bad example. Random, normal, and independent. Normal. Successes was 37. Failures was 63. Both greater than 10. Independent. 100 is less than 10% of Dunbar's population. Okay, pardon me, the announcements came on and got in my video. No biggie. C, conditions. Now, actually calculate it. All right, so here's where we get to the good stuff, the math. We need some numbers. P hat, plus or minus, Z star, square root, P hat, Q hat over N. P hat, 0.37. That's the only number I really know. It's probably close. Who knows? Plus or minus. Z star. Now, this, I went 90% just to give you an example that's not 95%. Usually it will be 95, but it doesn't matter. If it's 90%, then my Z star value is 1.645. Square root 0.37 times 0.63 over 100. I'm going to magically zoom into the future where these numbers have been calculated. And there's that. All right, just some simple calculator work. I got about 29% to about 45%. Kind of a big range, you know. Remember what that means. That means I am 90% sure that the true number is somewhere in between 29 and 45%. All right, right in the middle of that, by the way, is 37%, my estimate. If 100 of us did this, 10 of us would be wrong, 90 of us would be right. Okay, that's just the chance you take with a confidence interval. Sometimes it's right, sometimes it's wrong. How often is it right? In this case, 90% of the time. So I went ahead to the last I, the interpret in context. I'm 90% confident that the interval 0.2906 to 0.4494 captures the proportion of PLD students who have taken an AP course. Pause this if you need to, but get that wording down because this is the first one with the numbers and the context in it. That's what your interpretation should look like every single time. I am 99% confident this video is over and I'm out.